How you doing, folks? I am here, Mr. Rose, to guide you through the War Games question. Now, this is going to be a little bit of a different setup because I'm limited to the tech that I brought with me. So I've got this camera that is facing me now. Not the best picture, but unlike the last videos, you're not going to see me because I'm just going to do the problem for you straight through. I'll try and fast forward some of the calculations, but let's get to it. We are going to get into War Games. All right, folks, here we go. So I'm going to read the question. I have it on my computer screen. I'm not going to read the whole thing out loud. I'm just going to put in the important information here. It's a whole lot of story. And then we know that Dr. J was standing and shaking when he spotted a tank 200 meters away. So I'm going to put Dr. J over here. That looks like good. And now I'm going to say there's a tank 200 meters away. Let me draw my tank. That looks like a spaceship tank. Yeah, that's what it is because that's apparently how I draw a tank. And we know the tank is moving at 15 meters per second, and it says perpendicular to perpendicular to his line of sight. So I'm gonna say the tank is moving up at 15 meters per second. And then it says that Dr. J knows that the speed of a bullet is 300 meters per second. At what horizontal angle must Dr. J aim? So that means I am looking. That was not the best triangle. I'm going to make that bigger. There we go. 15 meters per second. We're looking for this, the angle that Dr. J needs to aim. Now, and I know that bullets travel at 300 meters per second. So if you drew a picture like this, that's great. You understand what's going on, but we cannot combine this particular triangle because I have a distance meters and I have speeds or velocity of meters per second and meters per second. So what we're doing is we need to build similar triangles with the same angle. So I'm looking and saying, hey, what are the pieces that are the same? Meters per second are the same. This is how we have to understand that vectors are representation of physical quantities, physical velocity quantities, and physical distance or displacement quantities. So I'm going to take my velocities that I know and build what I'll call a velocity triangle. So my velocity triangle has the tank moving at 15 meters per second, has Dr. J over there, and we know that we fire bullets at 300 meters per second. I'm going to put this dotted line as my baseline. We're looking for angle theta. Again, I'm combining the like units. Now, if you want, you can do this to scale. I wouldn't do this one to scale. I would do this by math. But if you wanted to make a scale, you could use a ruler and a protractor. That would totally be fine. So I'm going to choose my favorite function, and I know that I have an opposite and a hypotenuse from Mr. Mastro's address there. So I'm going to say sine of theta is equal to opposite 15 meters per second divided by 300 meters per second. That means I know my angle is the inverse sine of 15 meters per second divided by 300 meters per second. My units cancel. Calculator. I have the inverse sine of 15 over 300, and I get 2.8659. I'm going to call it 2.866. I'm going to carry an extra decimal. Theta is equal to 2.866 degrees. I'm just going to carry that extra decimal so I'm a little bit more accurate with my answer. So now that I know this, I'm going to build a similar triangle. For you geometry folk, you should know what that is. For you algebra folk, again, a similar triangle is just a triangle with similar measurements, and that similar measurement is going to be the angle. Because as we learned, sine, cosine, and tangents are just ratios. So essentially, I'm building now a different type of triangle at that same angle, keeping my ratios the same. So I know now that the tank was 200 meters away. and I know that I need to aim at an angle of 2.866 degrees. What I need to figure out is how far the tank is going to travel at that amount of time. Well, again, similar triangles. Now I have an angle. I don't know that side, but I know the adjacent side. I choose my favorite function again, and I say the tangent, well, I guess my different favorite function of my angle, 2.866 degrees, is equal to opposite y divided by adjacent 200 meters. I multiply both sides by my 200 meters, 200 meters. That cancels out. And then I know my distance that the tank will travel if I fire a bullet at 300 meters per second while the tank is traveling at 15 meters per second at that exact same angle. Because, again, this is a real physical thing. Dr. J is 200 meters away while aiming to hit the tank up there. So I know that comes out to 200 times the tangent of 2.866 degrees. That comes out to 10.01. I'm just going to call it 10 meters. 10.0 meters. So what that means is the tank will travel, this is part A, this is part B. The tank will travel 10 meters if Dr. J is 200 meters apart and he is aiming at that 2.866 degree angle, shooting bullets at 300 meters per second. Hopefully this made a little bit of sense. By all means, check your work. If you have any questions, drop me an email and I will see you all soon.